we've got 2 hours. We thought that what we'd do is we'd have 3 quick presentations and then go to birds of a feather or a bunch of Q&A and things like that so we can get the burning questions. For the birds of a feather, I was thinking of splitting it up by the things we're going to be presenting, but if anybody else has any suggestions, we'll take those at the end and decide what we can do. So we'll kick it off with Compose and Kubernetes, which is one of the newer things we've got in our team. We'll then be looking at Docker App and finally at Docker Compose and Docker Pi. So with that, I'll let Simon talk about Compose and Kubernetes.
Yes, so hello, so my name is Simon Ferquel. I work at Docker in the Paris office, mainly on Docker App, Compose and Kubernetes, and the Synapse ecosystem. So I start with what is Compose and Kubernetes, what problems it tries to solve, and as this is the OSS Summit, then I dig a little bit on how it is architectured, what is our developer workflow for working on it, and what is the future work that we want to do, and that might include your participation if you're interested in that. So Compose and Kubernetes is an extension to the Kubernetes API, and it's open source. And what it does is that it brings a new high-level resource to the Kubernetes API, representing multi-services applications. And it's compatible with the Kubernetes airbag system, so that it's secured in the same way as any other Kubernetes resources. And one of its value proposition is to be interoperable with Docker Compose files. It's on GitHub. I'll show you the link through this session. And so why did we do that? So the main thing is that we found that for describing multi-service applications, Docker Compose is really simple. It's just really straightforward to read and modify and edit. So in this example, I have just a simple WordPress application with 2 services. We can see that there are volumes declared. There are things like environment variables and things like that. And everything is really compact and straightforward. In comparison, Kubernetes YAML is not simple. It's really verbose. It's really powerful as well because you can dig pretty much very deep inside the Kubernetes API with kubeyaml. But you lose focus on your high-level constructs. Like this amount of code doesn't even represent the same thing as the very short compose file I showed you before. And we lose the simplicity and the focus that we have on higher level objects. So that's why we wanted to do that. So how it works basically, when you install Compose and Kubernetes on your kube cluster, you get a new API endpoint for managing what we call stacks. And that exposes CRUD operations like any other Kubernetes resource. It's the same style of API. In addition to that, we also deploy what we call the Compose controller, which actually breaks down your stacks into lower level Kubernetes objects. It's a very standard way of doing things in Kubernetes, and it's actually like that everything is done in the Kubernetes API. Like you have a deployment controller that will break down your deployment into replica set, a replica set that will break down your replica set into pods, etc., etc. And so we also have a small part. We also own a small part of the Docker CLI that does a conversion from a compose file into this stack data structure. That's a very simple base. So here I do a simple demo. So I will work with this very simple compose file. I have just three services in it. One which will expose a port, one which implements a business logic and that is deployed in multiple replicas, multiple replicas, and a DB that will have to use a persistent volume. So to deploy this one, I can just use my CLI. So my current context on the CLI uses a Kubernetes and the Kubernetes endpoint by default for managing stacks. That's something that we added to the CLI recently. And so I can just do a Docker stack deploy, pass my compose file, name it. And this will just create the stack structure. And we also watch for pods as they arrive so that we make sure that your stack is actually healthy. If I can use the Docker CLI to list my stacks, etc. But what I'd like to show you is more what is a stack from a Kubernetes API perspective. And as it's a standard API extension, I actually can manage my stacks also with kubectl. So I can do a kubectl get stacks. And I see that my demo object is here. And I also can do things. Oh, sorry, I can also do more detailed thing like stacks demo and output it as JSON. No, it's no. It's -o. Sorry. So what we see here is that my stack object is actually like any other Kubernetes object. It has an API version, a kind, some standard Kubernetes metadata like a name, the namespace, etc., etc. And the spec is actually very close to what we have in the compose file. It's actually based on the same data structure that we just cleaned up with only what we support in Composant Kubernetes. But I can see that my service DB has some volume mounts. I can see that my web service has some ports exposed. And I can see that my words deployment has multiple replicas. And so what did the Compose controller from that? Actually, it has just break this down into some Kubernetes services, some Kubernetes deployments, and for the DB, it's actually created a stateful set because we saw that there was a persistent volume associated with it. We can also see that the word is scaled. The word service is actually scaled using the deployments scaling feature. And yeah, so basically it does very simple things, but it does it well, and it does it in a manner that now I manage my application through this stack object. And actually, as it's based on a reconciliation model, I can also do some crazy things like kubectl delete deploy .-web. So I will just remove the deployment, but the reconciliation controller will just look for those kind of events and take corrective actions. So if I do kubectl getl, actually my web deployment has just been recreated by Composant Kubernetes because it took this corrective action. So that's actually in parity with what every Kubernetes reconciliation controller does. Like if you remove a pad that is part of deployment, the pod will be recreated for you. Okay, so enough for this little demo. So now how we built and how the architecture of composant Kubernetes has evolved. So for a bit of context, there is actually two ways to extend the Kubernetes API surface with new resources. One is CRD, and it's probably the easiest way to do that, and it's actually, I think, the preferred way to do that. And when we started, we started with this system. So basically, a CRD is just declaring that you have a new kind of resource, and basically the whole REST API is actually implemented by the Kube API itself, and you don't have anything to do about that. But it lacks a little bit of control, so you cannot actually validate any payload. You cannot inject default values and things like that. It has changed a little bit with mutating webhooks and things like that. You can actually do that now, but when we started, it didn't exist. So we decided to move to another technique, which is API aggregation. So the API aggregation layer in Kubernetes allows you to bring your own API server with your own custom logic for doing payload validation, for doing any crazy things that you do, and it will just aggregate that inside the Kube API itself. So it's like using Kube API as a Nginx just on front of your API, and benefit from the Kube API airbag system as well. So now we do that, and it allows us to do a few things like being able to expose sub-resources so that we have clean API for doing scale, for getting logs and things like that from a stack. And it allows us to do things like recording user identity and do something that is a bit strange, but actually every action that Composant Kube does is actually impersonated with the user that created the stack. So it was a decision made for security and to avoid to have privilege escalations. But I will come back on that a little bit later. So for Composant Kubernetes, the current architecture is a bit like that. So we have the Kubernetes cluster that has the Kubernetes central API server. And along that, we have our own API server that lives in its own deployment with its own HCT backing store for storing our resource. And along that, we have the Compose controller, which is where the main logic is. It's the component that listens for events on the Kubernetes API and that take actions like breaking a stack into sub-resources. So I said that we do user impersonation. That's something that come along when we tested that. Is that as soon for most of the reconciliation controller that we have in Kubernetes, as soon as you get the right to create a resource, you get exactly the same rights as the reconciliation controller that breaks down that into sub-resource. And for deployments, stateful set, etc., it might not be a problem, but when we expose the right to actually create a whole stack, actually we expose the right to create many things like persistent volumes, deployments, stateful set, services, and even load balance services. So it might be a bit problematic to give all those rights implicitly by giving access to those stack resources. So what we do is that when you create a stack, our API server will record the user identity, and when the reconciliation controller does this reconciliation, it actually impersonates the user that created the resource. So it will act as this user and get exactly those rights. So if my user doesn't have the rights to create a load balance service, and your stack contains a load balance service, it will actually fail. It won't be able to reconcile. But that's not the cleanest way to do that, but it works. We also needed the API server things because we have some multi-versioning issues. We started with slightly different kind of resources where actually the compose parsing, the compose file parsing was done server side. And so we have a V1 beta 1 endpoint that has really not the same shape as a V1 beta 2. And so we couldn't use the CRD for doing things like handling both versions at the same time. So now a little demo for the developer workflow, and what I will do is just add a feature inside Compose and Kubernetes. And so the first thing that the thing that we'll do is that we'll try to give control over the pull policy of a given service in a stack. So first thing that we'll need to do is to actually modify the object model. So here is the V1 alpha 3 resource definitions. So we have this stack object, which is very standard Kubernetes runtime object with type meta, object metadata, and a spec. And in this spec, we have a bunch of service configs. And so what I will do is just add this pull policy field, so that we now can specify a pull policy when we describe a service. Once I've done that, I need to change my reconciliation controller so that it gets aware of the presence of this field. And so this happened in this internal convert package there. So what does convert is that it starts from, it starts from a stack resource, and it wants to output a bunch of Kubernetes finer grain resources. And as part of that, we have this two-pod template function that gets a service config, and that should return a pod template spec, which is an object, a native Kubernetes object. So what I do there is that I prepared the code because I don't want to code live. What I did there is that we have this logic to image pull policy that originally didn't give any control to the user, and so now I want to look at what was specified in the spec, and if something was specified, I want to respect that. So I will just explain the logic a little bit. So before we could add a pull policy, we had a very simple logic. It was if the image has a latest tag, we will use pull always. And otherwise, we will use pull if not present. It was a random decision made really early when we did that, and so we figured that it's not giving enough control to the user, so we wanted to implement that. So now, if you explicitly specify a pull policy, we check if it's a valid value, like pull always, pull if not present, pull never. And if it's the case, we will do that. We will respect that. And so if I go to where we actually use that, so we now get a pull policy, which is based on the image name and the specified pull policy in the spec. And we affect it to the pod template spec as well. So where is it? It's there. So when we create this this thing, it's there. So it's a pretty straightforward way. Actually, when we want to add a feature, we just add a field in our spec structure, and then we just modify our conversion functions for just doing a slightly different breaking non-logic. Eventually, if I had to do that, I would also add many unit tests and things like that, and also end-to-end test. And that's something that we're really happy about the current state of the end-to-end test facility that we have with Composant Kubernetes. And how it works is that we use Ginkgo to describe our tests, but the most important part is how we set up those end-to-end tests. The tricky part is how do you spin a new Kubernetes cluster, run a bunch of tests, and shut it down. We used to have a custom technology which would spin up things on AWS, but it was quite slow, and every time a new version of Kubernetes got out, we will break for whatever reason. And so now we use something that is called Kind. I don't know if you guys have used that. It's Kind for Kubernetes in Docker. And actually, it gives you the ability to spin up a full working cluster inside a Docker container, a bit like what we have with Docker in Docker. And so we use that. And so I just want to show you, or maybe I have no time to do that locally. But actually, we can run it locally, but we also have that in our CI. I just want to show you a little bit how it looks like. So in our CI, we actually test Composant Kubernetes with a bunch of Kubernetes version, 1.14, 1.11, 1.13. And each time we do a PR, we actually spin up a new kind of environment. No, it's not this one. It's, yeah. We spin up a new cluster using this kind tool. And what I want to show you is the timing. So for both creating the kind of environment, the whole cluster, and running our end-to-end test suite, the overall operation takes less than 6 minutes, which I think is really cool. and actually we use that, and we are able to run in parallel many versions of Kubernetes and run our test on that. And with this, I will just add just a few things about our future work. So what we want to do is basically we want to go back to CRD at some point. But for doing this, we need conversion webhooks to land in the Kubernetes API machinery. We also want to have better persistent volume support because for now we only support very few scenarios. We want also to have ingress controller support and application CRD integration. If you're interested in that, I think it's a very good project from the AppSig. And please contribute all those things. You can pick things up in our repo and contribute and help shape what Composant Kubernetes should be in the future. Thanks.
Thanks, Simon. So, sorry, we had to cut you off. We've got other things we want to talk about as well. Are there any questions just while we're on this, so that if before anybody forgets their question? Oh, I see one down there. I'm going to come get you.
Maybe slight digression, but when they created a database, he said he used MySQL in this example. So if we are going to update an application which needs something additional in the DB, how does this thing work? I mean, when you are making an update, we are always talking about application update, but what about we need to add a column or change the size? How does the application recreate in this case?
So it has a persistent volume. So when you update the application, if the database piece changes, it'll rerun or relaunch the container with the new image, and
then you will lose the data because you are changing something from a structure.
Actually, you don't lose it because what we do is that we create stateful sets, and as soon as you don't change the persistent volume definition itself, it will pick up the old data.
Okay, maybe I'll ask. So, any new data? So, if you have, what I meant to say is, you add a new column from the application. At what stage you are adding that column? So, and then from application you are trying to insert new data, right? In this example, you have taken from an empty state where you took an image for a MySQL. You took one application service and one DB service, and then you have just launched it. So it is starting from scratch. So my point is, if you want to make an increment, then how does the application behave from a DB perspective?
Yeah, I think I will come to you offline because we are a bit short of time. But, yeah.
Are there any other questions?
I need to prepare.
No? Okay. Well, when we do the birds of a feather, we'll try and split the room up into the different projects, and then that way, if you have a burning question, you can speak to the most relevant person. All right, so in this section, we're going to be introducing Docker App. You saw it in both days of the keynotes, but Silvin will be doing yet another demo, I guess, and hopefully it'll give you a better idea of what it looks like. The idea of Docker App is basically to give us a way of packaging Compose.
Okay. Welcome to this introduction to Docker App, and welcome to this open source summit. I'm Silvin Lubecki. I'm a software developer at Docker in the Paris office, like Simon, Chris, and Ulysses over there. And we work on the application definition. And today I'm going to talk about Docker App. So what is Docker App? Docker App is a Docker CLI plugin, a brand new plugin to create, share, and install applications. So for that, we created a new package on top of Compose files, but we extended it with metadata because we thought that it was missing. So we added like name, version, description, maintainers, and also a set of parameters. So that's basically the idea of Docker App package. The idea is to reuse the Compose file that you already have and extend it. And now we can share application using container registries. With that, we can reuse your same application across all your environments thanks to the parameters. With that, you can customize your application. So if you have a dev environment, a production environment, you have different settings. We have some customers who have replicated their Compose files, and they have to maintain them across all their environments. So with that, with Docker App, you just have only one Compose file and multiple parameters files. And we support also the same workflow as images with application. So you can push or pull your application on a registry, but also promote it, like on DTR. And we are working on signing the application itself. About the installation, we use CNAB for that. I won't talk about CNAB during this short introduction, but there is this afternoon a CNAB panel. And so please go if you're interested. So Docker App is a full CNAB compliant client, which means that it can install Docker application, but also any CNAB package. But we abstract the Synapse specifications, and we are very opinionated about that. So the idea that you won't see Synapse unless you really want to. We also construct Docker App on top of Docker Stack Deploy, so it has the same features, and you can deploy on Swarm cluster and, as we saw, on Kubernetes cluster. And it also supports Docker context, so the idea is it's an easy way to switch between your environments for ops or for developers. So now, why Docker App? So we think that Compose is a great thing for defining an application. It's simple. You focus on the application structure, not on API details. It's not too verbose and easy to read and write. But it's difficult to share. Hopefully you're using a version control system with your Compose files. But yeah, that's not a good way to share. We think that using registries is a better way. But also we added metadata. So we think it's useful for operators and other developers to check who made this application, what does it do, what is this version. And also, and we see that during the demo, you can easily see what are the parameters for the applications. So you can communicate on what can be changed on the install without reading the Compose file itself. So yeah, parameters provide a good way to check and communicate what can be changed. And all of this facilitates the developer to operator handover. Okay, so it's time for demo. Yeah. Sorry. So I prepared what looks like a common developer environment. So I'm on my local here, my local machine. Yeah, I'm using Play with Docker because we have some Wi-Fi issues. And I created a Swarm cluster with just a manager and one worker. Okay, so the idea is that I will deploy my application locally, and then I'll try to deploy on my production or development cluster. So if I check my contexts, I have two contexts, one default, which is my current machine, and my prod cluster. So right now I'm using the default one. So if I check just my current, okay, so there's only one container. And if I check my cluster, there's nothing on it, okay? So I already have a Docker Compose file, a simple one, which is the famous voting app. So from that, I will create an application. So we have this new command, Docker App, with some commands, and we will check them after. And then I'll initialize my application, so Docker App init. And so I'm creating a new voting app with a description, and I'll set a maintainer. Okay, let's just check that. Okay, it created a new directory, and hopefully, sorry. Yeah, and inside we will find our metadata, parameters, and Docker Compose files. and it copied the Docker Compose file. So now we can forget the old one and use this one instead. Yes, okay. And I can inspect. Oh, what happens? So what it does is it will show the name of the app, version, the maintainers, description, then list the services, how many replicas, the ports, the image it uses, and list networks, volumes, secrets, etc. So that's an easy way to check what is inside an application. But now I will add some parameters on this. And for example, I'll add a parameter on replicas because I don't want to have the same replicas for development and for production. I want more on production, maybe. So just like this. And maybe I can configure also the ports. So parameters are you can add anything here. It's your call. Oh, sorry. Right. Thank you. Live coding.
Mirror your screen so you can type in here as well. Maybe that's easier.
Sorry.
You can mirror your screen so you can.
Yeah, but yeah. Oh, whatever. Okay, and maybe on another service, like the result service, which also exposes a port. Let me check. I'll add another. And here I also configure the ports. Okay, so now I added some parameters, but I don't added any default value, so it should not work. So for that, I have a validate command, which can check if something is missing. And yes, it fails to load the compose files. There are some missing values like vote.replicas. So I'll add them. So this is just a simple YAML. Okay. What? Oh, that's fine, I guess. Let's validate again. Okay. Okay, right. Thank you. That's what you were saying. Okay, thank you, YAML. Oh, shit. Oh no, I think I lose. Okay, but okay, better. So it's validated, and now what I can do is render my application, and what it will do is produce a compose file filling the holes with default parameters. So let's check that. Okay, so here my vote service has 2 replicas. But now what I can do is override them at runtime. So yeah, I change my ports and how much replicas I? Okay, no replicas, of course. Okay, better. Okay, so I have 25 replicas. Change my ports. Okay. So what I can do with that is use my my current workflow. So I can just, if I want, pipe to Docker Compose. Oh, sorry, it's difficult. But also on Docker Stack Deploy if I want. But we also provide the Docker App Install command. And here I will just install the voting app, modifying the ports. Yes, like this. So it's installing locally. And it should see some pages here. It should open. Oh yeah, I need to scroll. Oh. No. Okay, so let me check the status of my installation. Oh, but I can list my installations. Oh, come on. So I have one installation. It's the result of the installation, not the current status, but just the last action we made on this installation, because we can install, we can upgrade the installation. I will query the status of this voting app. Okay, it's my voting app, of course. No? Yes. So here you can check what was installed and how and when. Check the name of the installation, of the application, the version you installed, what were the parameters you used. And after that, it does a Docker stack services on the stack. So yeah, so this stack is installed, it should work. I don't know why the badges are not there, but at least that's fine, just trust me. So then I can install my application again, but this time using, oh, no. I'm sorry, play with Docker has some bugs. But this time, I'll use a target context to target my prod cluster. And it will install the same application, but on this warm cluster. So if I run docker -- context equal prod cluster, PS. Yes, it has been deployed. So I can also upgrade the same way, upgrade my application. I can uninstall it. And what else? Oh yeah, of course, push. So I will push my application using the workshop / my voting app OSS submit. Okay, maybe I need a Docker login before. And it's pushing. So it's pushing your application files, but also all the images referenced in the services. So you will have everything in the same repo, successfully pushed. You can find the digest here. And hopefully, if I go to hub.docker.com, okay, it's there. And of course, I can pull it. And I can inspect it directly. Etc. or render, and any command will work. And that's it for the demo. Yep. So future work about Docker App. We are now on the 0.8 version, beta 2. We will be released with Docker CLI and Docker Engine 1903. But for further version, we will work on build args, because right now the only thing you can't parameter are image names, and some customers want to parameterize them. We will explain that later during the Battle of Fever, if you want. We will also integrate with BuildX, because you already saw that BuildX can build compose files, so to have a seamless and unified UX. Also, there's some customer who want to enable or disable services for local development. So you just install the app without one or more services and run those services locally and make it that work. And also the CNAB 1.0 specification will come soon. So we try to be up to date. So we have to to make some modification with that. And yeah, contributions are welcome. Those are open source repo for Docker App and Docker Compose. And Ulysses and Joffrey will talk about that. Thank you.
All right. Oh, questions ready. Here we go.
I have 4 questions, okay?
We'll start. Yeah, go ahead. And it's the other.
So my first question is are you considering to, or isn't it better to move the metadata into the compose file instead of having a different file for this?
I can answer that one. What we're trying to do here is be additive, so that you can still use existing flows and not create a new format. Because every time you create a new format, everybody has to move to the new format. This way, if you want your old flow, you can keep it. If you want to use this, you can easily move to it.
So the other question is, can I create different values files?
Oh yeah.
and choose one or the other?
Yeah, I forgot to demo that, but you can you can create over parameters files like prod parameters, and during installation or render any command, just dash parameter file equal and use this file.
Okay. The question is, can I apply this to Kubernetes or just to Swarm?
No, it works the same way on Swarm and Kubernetes.
And my last question is, can I export this to Helm? Can I say create a Helm chart with this?
No, you can't right now, because the application is defined in Compose, and there's no conversion from Compose to Helm as yet. They kind of serve the same purpose, so it's yeah, not yet. Yeah. I think he's having.
Can I upload an app to an existing registry?
Yes. So yes, any OCI compliant registry will work. We didn't want to make a new app catalog. We're lazy people. We're developers. So we said the hub exists. Let's use that.
For the plugin support in the Docker command line, do you have to install Docker App separately, or is this now being packaged with the Docker command line?
So the Docker plugin stuff is interesting. Let me go to the front maybe, but it's actually purely for internal like separation of concerns. The Docker CLI is a big project, open source, and stringently constrained. So it's just to make it so teams can develop plugins internally. That's the intention. They will be shipped as part of Docker CLI. So when you install the Docker CLI package or Docker itself, Docker Desktop, or whatever, the Docker plugins will come with that. You don't have to do anything. Going forwards, if there's lots of interest, we may investigate opening up plugins to other people as well. It was an internal thing that was massively successful unexpectedly. Yeah. Any other questions? Nope. Okay. Are you guys ready? All right. Well then, yeah, you can just take it away.
All right. Hi, my name is Joffrey. I work at a startup called Brandless, and I'm also the maintainer on the Python SDK. So I'm going to talk a little bit about that, and then after that, Ulysses will take over, and he will speak about the latest changes in Compose. Going too far. Yeah, so what I'm going to talk about as far as the SDK is concerned is kind of the latest improvements in the past few months, things you might have missed, big ticket items, and then the things that we're going to work on next in the short term and as well as in the longer term. So yeah, for those who are not necessarily familiar with the Python SDK, some of you may be using it directly. Others will probably be using it indirectly if you have ever used Compose or Ansible or a bunch of other tools. So yeah, it's basically it's a Python library that lets you like send commands to the engine API. Oh, the slide is crooked. So things you might have missed in the past few months. So of course we're like always improving the library with like new additions to the API as they come to the stable releases of Docker. But on top of that, we have some other improvements. So in August of last year, we released version 3.5, which added support for Python 3.7 and greatly improved the support for credential stores. Especially for those of you who are on Windows. So if that's something you're interested in, that's a pretty good thing. In November of last year, we released 3.6. In 3.6, we added experimental support for connecting to the Docker daemon with the SSH protocol. I say experimental because it wasn't perfect back then. It's probably still not now, but I'm going to get back to that. Earlier this year, in January, we released 3.7. In 3.7, we have support for multiplexed attached streams. So that means when you attach or when you like do a exec, you can now have like separate streams for standard out and standard error. This has been a long time coming, but it's finally here, so that's pretty exciting. And then we also added support for using the proxy values that you configure in your config.json. That was already in CLI and in Compose for a while, but we now have it in the SDK as well, which is pretty useful. And finally, so in March of this year, we released 3.7.2, which has several bug fixes for the SSH support. So it's, I'm going to jinx it by saying it's stable, but it's stable. So yeah, so a little bit about the short-term future. We're going to release 4.0 soon. So it's not like a big like feature release or anything like that, but it's good. We're going to make some like architectural changes and kind of get rid of some of the tech debt, stuff like that. So among the things that are notable, we're dropping support for Python 3.3 and 3.4, which are end of life now. So we'll try to like make maybe a patch release for 3.7. So for some bug fixes that we'll drop in this, but yeah, going forward, we're definitely like interested in like supporting the newer versions of Python. The proxy values from config.json that I mentioned before, they now will be injected by default. Right now it's based on a parameter, but obviously like the CLI behaves like that. We just didn't want to like introduce breaking changes in a point release before. So another thing that's notable is the credential store handling used to be a separate library. That's how we decided to go was at the beginning, but it doesn't really make a lot of sense because the only thing that uses it is Docker.py, so now it's part of the core library. And of course, there's like new API functionality as you would expect from a release and bug fixes. So I know I put an exclamation mark here. Bug fixes are not necessarily exciting unless you're the one that's having a bug. But so yeah, I don't know. As far as the longer term things I want to work on, of course you've seen like in the previous demos, the Docker context switching. That's definitely something we want to have support for in the SDK as well, so that people that are developing like user-facing tools with the SDK can use it. For those who like are familiar with the Python ecosystem and the way Python has evolved recently, in recent versions we've seen type hinting added, as well as coroutine support in the core language. So that's definitely some of the things I want to explore because they're pretty exciting. And some of you will say, well, that was like 2 or 3 years ago. What are you doing? The thing is, because those are not in Python 2.7 and we really need to support Python 2 for a while still, those haven't really been topics before, but now that Python 2.7 is going to be deprecated at the end of this year, it makes a lot more sense to look at those. So yeah. And then as far as our docs are concerned, I really want to like, we have like pretty solid API docs, but I want like more kind of tutorial style docs to explain like how to do like certain things that are like common requests that I see on the issue tracker. So that's definitely on my roadmap as well. And then other things, I mean, we have like an open like issue tracker. We like obviously love pull requests. If you're interested in helping us out, like, yeah, excited about that. So, and yeah, that's pretty much it for me. I'm gonna hand it over to Ulysses to talk about Compose.
Hello everybody, I'm Ulysses. I work with Simon and Silvin and Chris Crone at the Paris office in the application definition team. So we do all the things related to development and the workflows. And yeah, what about Compose? The idea here is to pass you the latest changes and the current work and a near future on Compose. So one thing that we are doing, I don't know how many of you have issues on GitHub. One thing that we changed like 2 months ago is that we are doing a triage. So people on the project is gonna pass through the recent issues and the last issues. So we can have lots of eyes every week. We change, and then we have everyone looking at the state of the project. One big change that we had now, it's not functional, but for the project, is that we did a big refactoring on the Docker file, because it was more one Docker file for the part of the integration tests, and another Docker file to go to the hub so you can use. And then we are just doing a kind of one ring to rule them all, so then we can have Alpine, Debian in the same Docker file using multi-stage build. I'm gonna show you after how it works. Now we just added, with the Alpine introduction, we have a binary that is linked against libmuscle. So that means that now you can do copies directly from the Docker Hub image into an Alpine container, and it works. Yeah, and of course we just expanded our CI test machine matrix for Alpine too. So it's not a build kit or multi-staging talk, but just to explain you how it's done. If we think, when we are using the normal Docker build, it's gonna go just linearly from top bottom. But when we are doing this with BuildKit, it's gonna make a graph. And then at the green part, the runtime target, you can see that we have just a really skinny part that's just the from, the entry point, of course, and just the copying of the binary from the other stages that are up. And then what happens is that if you look at the first part, the grouped args, you're going to see Docker version, Python version, build Alpine version, Debian version. When I say Debian, doesn't mean that you need a Debian or from Debian to make it run. It's just that this is the distribution that we use on our Jenkins, but it just means that you need glibc because it's linked against it, but the binary doesn't have any kind of Debian dependency or whatever. So then what's going to happen, the last arg is the build platform. This is the key for using the same Docker file to two different things. So then when we're going to pass the build platform on the green part, it's going to do a from runtime here, from runtime build platform, and its build platform is going to be, for example, Alpine, which is going to be Alpine here or build dash if we put Alpine after. And then here is the dichotomy that's gonna do the difference, because the build is equal. We are working with Python and there's no specifics about it. But then the dependencies, if we are in the Alpine part, it's gonna just put, for example, muscle dev and all the OpenSSL, because we just introduced that because of Paramiko, the SSH part that was introduced in Docker Py, and we don't even need like muscle or whatever for Debian. Yeah, that's pretty much it. So I'm gonna just show. Yeah, this is the graph, and then here is the dichotomy. So I'm gonna show you how it works. So in case that you want to use it. So here, is that big enough? Oop. Up. Yeah, it's not that responsive. Yeah, now it's too. Now? Yeah, I think it's good. So it's gonna run really, really fast because I'm using BuildKit, and I already practiced that before the talk, of course. But believe me, like, it's open source. You can trust me. So then, what's going to happen here is that when we run that, we pass a build arg with the platform that I just told you before, and the path in the graph, it's gonna lead to an Alpine in the top. And then you can see that we get the Alpine version of Python and things like that. If we just change, it's the same line, but we just change the build platform here for Debian, it's gonna get the Debian path in the build kit graph actually. And we can see that we have a Debian stretch. It's like latest slim version. Yeah, that's just this for. And then with this, what we can do before our Jenkins CI was just with this part, these stages, the build image, which was a Debian before, and the two latest versions of Docker, the CLI, and the two latest versions on major Python 3.7 and 2.7. And then now we have this, which is a build for Alpine, a build for Debian, and then all the implementations on it. Yeah, this is already done, and things that are going to come that is quite interesting is the build kit support. The build kit support is going to be pretty much on leveraging on the CLI. So we're just going to bypass to the CLI the responsibility of the build. Because we can talk about why in the birds of a feather, we'll be glad to do that. This is a PR that started. It started with -- exec, was the contributor, first time contributor. That's quite nice. But maybe we're gonna change that for something -- CLI or something more business and not just exec, because we have also Docker exec, so to avoid this kind of thing. Yeah, so it's quite simple. We just add this on your build part. Okay, if I do clear. So the idea here, I just do a normal build, which is gonna use the direct build using Docker Py. That doesn't support build kit for now. And then you have the normal build there. And with the PR, this is, yeah, trust me, this is build kit, but it doesn't show like this with the colors and things like that, because the shell we are using, it's not a TTY shell, so it's just gonna take off all the coloring and carriage return and stuff. But this is build kit when you don't have this kind of feature in the shell. Yeah, that's it. It just works fine. We just need some shaping on this part. Yeah, and I think that's it. We have also to integrate the context that is massively used, and it's really nice. So you can just switch things. This is it's going to have a first part on Docker Py, and then we integrate this also in Docker Compose, which is going to be like the easiest part, but it's to come. And yeah, that's it. Thank you, everyone.